So hello everyone, my name is Marlis Bian S. Apat, a graduate from Bachelor of Science in Electrical Engineering. I am currently working in a hospital and your dear principal contacted us, me and my friends. So he contacted us so that we can share to you guys some topics and lessons that you will surely encounter if you take this kind of field. So I hope in the end we can share you some knowledge and you will learn something from us, and I hope to everyone to have a great day. So for today's topic, I'm gonna teach you on how to solve the capacitors in series. When capacitors are connected one after another, they are said to be in series. For capacitors in series, the total capacitors can be found by adding the reciprocals of the individual capacitances and taking the reciprocal of the sum. If capacitors are connected one after the other, in this way we call them capacitors hooked up in series. So here, we're gonna use three capacitors. On the left, we have the battery, and let's say that the battery's voltage is 50 volts. And here we have the capacitors, capacitor 1, 2, and 3. For capacitor 1 has the capacitance of 2 farads, C2 has 3 farads, and capacitor 3 has 5 farads. So what is the equivalent capacitance in this circuit? That's the first thing we'll look for. A simple way to find the equivalent capacitance in a series circuit is going to be equivalent capacitance equals 1 over C1 plus 1 over C2 plus 1 over C3 minus 1. And now we'll have this equals 1 over C2. The 2, we got it from the capacitor's capacitance of C1, C2, C3's farads. So now we'll have this 1 over 2 plus 1 over 3 plus 1 over 5. Now solve it so that we can have the equivalent capacitance, and it is about 0.9677 farads. Now, with this information, how can we find the voltage across each of the capacitors? Sometimes, you may need to find the voltage of just one of the capacitor, and with that, you can find the potential energy is stored in the capacitor. Now, let's focus on finding the voltage of each. So once you have the equivalent capacitance, which is this, the next thing you do is to calculate the charge. In calculating the charge, we have Q equals equivalent capacitance voltage. In a series circuit, the voltages across each capacitor will be different if the capacitance is different. In the series circuit, the charge stored on each capacitor is the same. So once we find Q, this Q will be the same as Q1, Q2, and Q3. They all equal to other. So now, let's find Q. Q is equals to the equivalent capacitance, which is 0.9677 times the total voltage. So we have 50 volts. So now we solve it and we'll get the total charge, which is 48.39. So now let's find the V1, V2, and the V3. The V1, it is going to be Q1 over C1. So we'll take the equivalent, the total charge, which is 48.39 over C1 which is 2, and it is equals to 24.2 volts. Now in C2, the C2 is gonna be Q2 over C2. Q1 and 2 is the same value. So we have 48.39 over 3, and it is equals to 16.1 volts. Lastly, to find C3 is gonna be Q3 over C3. So in that, we have Q3, it's going to be 48.39, and C3 is going to be 5. So 48.39 over 5. And it is equals to 9.7 volts. Now, before I forgot, these volts are the voltage across C1, C2, and C3. So the voltage across of C1 is 24.2. The voltage across of C2 is, we have 16.1 volts. And lastly, we have the voltage across of C3 is 9.7 volts. Notice that the total voltage is V1 plus V2 plus V3. So V1 is 24.2, V2 is 16.1, and V3 is 9.7. Now, we need to add these values. So, in order to get 50 volts, which is equivalent to our battery. That's how you know if your answer is correct. It has to agree with one another. The sum of these three values has to equal the battery's voltage. So the sum of these three values is equivalent to the battery's voltage. So we can see that the sum of these three values is equivalent to 50 voltage, which is similar to the battery's voltage in here. Lastly, let's calculate the potential voltage of C2. So C2 is going to be, in here, we have 1/2 and is equals to CV squared. So 1/2, this capacitance, we have 3 farads, and the total voltage of C2 is 16.1 squared. So we need to solve it, and in order to get the value, solve it, and you'll get the equivalent answer of 388.8 joules. So thank you for listening, and I hope you learn a lot from today's topic.